Okay, on these problems, this is something that I have not seen before. So all I have with a question, so I'm trying to go by what I can interpret it as. So your book may be approaching this thing differently, and if it is, this may not be as helpful. It just depends on what they expect of you. So it's kind of using the idea of polynomials and probability. So the first thing, you're working with all these different kinds of dice problems. They call them number cubes. I still call them dice. So when I'm looking at dice problems, I typically will give a description like this. We look at the numbers 1 through 6. You have two different dice. You're rolling. And then these are all the possible outcomes. Now, if you look at this, we have, let me get my pen up here. We've got 6 choices for our first die, and then 6 choices for the next. There's 36 possible outcomes. And all the outcomes are kind of listed right here. So the first die rolls a 1, the second die rolls a 4, gives me that 1, 4. Now, these are all looking at the sums of the dice. So if I add these two numbers together, I get these sums. So what's the probability that I get a sum of 4? Well, I have 3 chances. You can see the numbers right here. There would be like 3 numbers out of 36. So it'd be 3 out of 36, 1/12. 7, you can see, is the most likely. And what happens here to get the most likely one, it's always right in the middle. So if I go right in the middle of 1 through 6, the average is 3.5. So each die would average 3.5. So if I roll 2 dice, my most likely one would be 3.5 plus 3.5, which gives me 7. So that's where the most likely one's going to come up. It's always going to tend to be in the middle. Now, what they're doing in the problems is approaching it by using polynomials, by using the idea of rules of exponents to generate this. So if we look at the rolls, and I still kept the rolls right here, it's 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6 going down, and you have x raised to those powers. When you multiply, notice I changed this to multiplication. When I multiply, we add our exponents. So the exponents represent the adding of the sums. But we can use software to be able to generate the list. So I still have, if I look at my 4s, there were still 3 x to the 4, so I got 3 4s, 3 sums of 4. Right here, I would have, if I look at my 6s, there's 1, 2, 3, 4, 5, there's 5 of the 6s. I got to kind of ignore the column part right here, these guys, because this is where I'm multiplying by. I need to have little different like edges here to make it clear that I'm just looking at the stuff in the middle. So what happens when I actually look at the polynomial that I have, it's going to be x plus x squared plus x cubed plus x to the 4th plus x to the 5th plus x to the 6th. I'm rolling it 2 times, so I'm squaring it. And if I go through, and if I did actually square this out, this would be the same thing as multiplying it out. I have 1x squared, I have 2x cubes, 3x to the 4th, 4x to the 5th, 5x to the 6s, 6x to the 7th, 5x to the 8th, 4x to the 9th, 3x to the 10th, 2x to the 11th, and an x to the 12th. Now, this right here is written in descending order, where the highest power starts. That's typically where you'll see them. Now, on the problems you're doing, most of the time they're giving you with raised to the 4th. So what I did is I'm going to Wolfram Alpha to be able to get the expansion. Now, I believe they did the expansion in your book. And this is where I'm not sure how much they gave you or what other resources they're providing you. But if you go to that website, wolframalpha.com, and I'll show you it right here, you can simply type in something you're trying to do. So let's say I want to expand, then I put in parentheses, and I want to do x plus x squared plus x cubed plus x raised to the fourth plus x raised to the fifth plus x raised to the sixth. And then I'm going to take this and I'm going to raise it to the fourth power, because that's what they had you do in the problems. And I think they gave you this one. So when it goes, it's going to do in the calculation, and this is where the numbers come from. So this is how I'm actually finding these values. So I'm not actually hand multiplying them out. I'm just utilizing these tools. Okay, so back to the PowerPoint. So when we expanded it, that's the result we just got. Now it asked you to see about building a histogram showing you all the possibilities. Now, if I look at my numbers here, what this represents, the numbers, 24 is my highest sum. I have 4 sums of 23. I have 10 sums of 22. I have 1 sum of 4, 4 sums of 5, 10 sums of 6s. So one of the questions to ask you is, why are these two the same? Well, the only way I get 23 from rolling 4 dice is I have to roll all 6s with 1 5. And I could have that 5 come up on any one of those 4 dice. That's what the 4 represents. Now, to get a sum of 5, I'd have to roll all 1s except for 1 2. If I roll 1 2, well, there's 4 dice, it could have been the 2. There's 4 different ways it could happen. So that's why those two are the same. And you get similar kinds of thinking when you do each one of these. The histogram you got should look something like this. Now, the most likely sum, if I'm doing 4 dice, when I do 1 die, the average of the dice, the average of the pieces right here, 1 through 6, if I add them all up, I get 7. I get 3.5 is what the average would be. I get a total. If I add up all these numbers, I'd have 10, 21 divided by 6, which if I reduce it, 3 goes into both those, is 7 halves, which equals 3.5. That's the average of a single roll. Well, if I do 4 rolls and I'm summing them, if I do 4 times 3.5, my average I should get is 14. That's where the middle is. It's nice and symmetric that you end up getting. So it ends up being this nice, really kind of a bell-shaped curve. And that's right where the middle is. Okay, total outcomes for 4 dice. Well, I've got 6 choices for my first die, 6 for the second, 6 for the third, and 6 for the fourth. So I get 6 to the fourth possibilities, which is 1296. That corresponds to exactly, if I added up all the coefficients, if I added 1 plus 4 plus 10 plus 20 plus 35 all the way down until I got down to the 1x to the fourth, it's going to add up to 1296. But this is much quicker than going through and adding up all those numbers. This is going to stay the same even if some of the numbers are exactly the same. Like let's say we had a die that had 2 5s. There's 6 sides to it, there's still going to be these many outcomes. And that's what you're going to base everything on. Okay. So, okay, I don't know why I was struggling right there. It wasn't moving forward. Okay, so we have, let's say, rolling 3 dice. Okay, so if I take this, I have x, x squared, x cubed, x to the fourth, x to the fifth, x to the sixth cubed. There's my results. And they wanted to know on this problem, again, there's 216 possibilities, total outcomes. And we want to know, and I forget what was it, I think the sum, I'm trying to remember what the question had asked you. We wanted to know that the sum was over 10, maybe that's what it was. You know, if they had those things, because that's what it looks like my numbers, or the sum is less than 10. So let me take a break here, and I'm going to go and take a look at your question again. Okay, so in the problem they asked you is the sum of the numbers was greater than 10. So I'm looking for all the numbers that were greater than 10. So the numbers that were greater than 10, when I look at these, oops, I'm trying to get my pen back here. Numbers are greater than 10. Well, this is 18, 17, 16, 15, 14, 13, 12, to 11. So this is where I got my numbers. 1, 3, 6, 10, 15, 21, 25, 27. If you add up all those numbers, it's 108. There were 216 possibilities. So my probability was 108 out of 216, which equals 1/2. So if I want to know what's the probability that it's 10 or less, it's also going to be 1/2. Okay, look at other outcomes. So most likely sum, again, take the average of the numbers on the dice. It's like this one right here. If I average 1 through 6, I get 3.5 times the number of dice you're using. Now, let's say the next problem they asked you, what if you replaced the 1 dot with 10? So now it's equal to 10 instead. Well, if I take the average of these, if I add them all up, I've got 4 and 6 is 10, 20, and then I have 2, 3, and 5. So I get 30. I've got 6 numbers, so 30 divided by 6. My sum is going to be 5. That's the average of one roll. On average, I'm going to roll 5. Now, take the number of dice you have, and that determines how many you're going to get. So if I'm going to do 4 rolls, my most likely outcome is going to be 20. That's my sum. Now, to find out what that sum is, I thought there might be a shortcut. Maybe there is inside of your book. So you may have to look at it to see if you don't have to expand it. The only way I knew how to do this thing initially was going to Wolfram Alpha, expanding this function, the one that basically the polynomial, raised to the 4th and rolling it 4 times, and then looking for the one with the 20th. That's this guy right here. I had 95 ways out of the 1,296. Now, it's still 1,296 possible outcomes because I still have 6 sides on the dice. So it's 6 times 6 times 6 times 6. That's where that number comes from. But I have to still find it this way. Now, if they have something else, a different method inside the book, then you should use that, but not be able to see what they use for their instruction because I've never seen problems done particularly like this before. Because I think they might be utilizing the technology like I am. Okay, now what happens if the dice has 2 5s? That was the next question. Well, I still have 6 sides. So I still have 6 outcomes. But my polynomial now, because I have 2 5s, I would have had x to the 5th plus x to the 5th. That's how I got 2x to the 5th. There's where the 2 is coming from, because I have 2 5s. The average of these, if I add up these numbers, because I got to add both the 5s, I get 20 out of 6. So that's the average of the dice. So most likely, if I had 4 of these, I would take 20 over 6 times 4. I'd have 80 out of 6. Now I got a decimal. It's 13.333. Well, this is closest to the number of 13. If I got 13.5, then 13 and 14 are both equally likely. But since this number is closest to 13, it's going to be the most likely. So when I expanded this out and I look at the one for 13, notice how the coefficient here is the biggest. Still out of 1296, I have 164 chances out of 1296. Notice the next most likely, the next closest whole number to 13.333 is 14. That's the next most likely. Then 12 would have been the next closest after that. That's why that one goes over to here. But we just had to expand it out. Now, the probability of the sum being 20, again, well, I had, did I choose the wrong thing? I think I did. I think I forgot to change this one. For sum of 20, I forgot to change this thing. I want to know the probability that the sum is 13. So this part is incorrect. So, whoops. probability that my sum is equal to 13 is going to be 164 over 1296. That was from the other problem. Forgot to change the numbers. Okay, now they did ask you to do this. Okay, they called Q is equal to P of X squared. So you're going to take that term and square it. Now I'm going to show you at least a method for multiplying this out without using Wolfram alpha. If you had to expand it, then they have had you expand it using something like that, but they didn't. This is what I would do. So I would just do a massive distributive rule. So we start with the x, and I'm going to take this x, and I'm going to multiply it by that x. So I get x times x is x squared. Then I do x times x squared is x cubed. X times x cubed is x to the fourth. Then x times x to the fourth is x to the fifth. X times 2x to the fifth is 2x to the sixth. Then I go to the next one. X squared times x is x cubed. X squared times x squared is x to the fourth. And I keep going until I get to x squared times 2x to the fifth, and I get 2x to the seventh. Then I'm take the x cubed through. When I multiply it through, it's going to give me these terms. Then I go x to the fourth. I'm going to multiply it through. So x to the fourth times x is x to the fifth. X to the fourth times x squared is x to the sixth. Then I get x to the seventh. Then I get x to the fourth times x to the fourth is x to the eighth. Then x to the fourth times 2x to the fifth is 2x to the ninth. Now when I get to this one, now my coefficients are going to change. 2x to the fifth times x is 2x to the sixth. I get 2x to the seventh, 2x to the eighth, until I get to the last one, which will be 4x to the 10th. And I just kind of line these up so I can add them together. And now I've got my expansion. Okay, so they asked you to do a couple different things, like what's Q of 1? Well, if I plug in 1, I'm going to get the total number of sums. There's 36 possibilities. They asked you about how much more likely was the evens and the odds. Well, all I got to do is look at the even powers here, and those represent my even rolls. So if I count up all the even ones, or I count up all the odd ones, if I count up all my odd ones, I've got, looking at my odd terms, because those are supposed to be less likely, I'd have 2 plus 4, so that's 6, 12, and then 20. There were 20 odd ones, which means there's 36 possibilities. There should be more. It seems like there's more odd terms than there are evens. Did I count them up wrong? Okay, but they're supposed to be the sums and so forth. I think they said it was more likely to come up with the evens. But I'm kind of looking at these things saying, maybe I got more odds. Unless I add these things wrong. Hopefully I didn't. Okay, but yeah, I have 6, 12, 16. Okay, that makes more sense. I have 16 that were odd, therefore 20 of them are even. So I just misadded when I was going over. So probability of getting an odd is 16 out of 36. Probability of getting an even sum is 20 out of 36. I'm just adding up the even exponents versus the odd exponents. Okay, then you have finally this board game kind of a problem on there. Well, 2 spins. If I go over and I spin it twice, the numbers are 1 through 10, and I want to know the probability of the sum is at least 18. This one, I don't have to do any kind of wild expansion or anything else. I should be able to figure it out without having to do that because it's only a few possible outcomes. So I'm going to think about my dice and what kind of possible outcomes to do. Well, if the numbers are 1 through 10, the best roll I can get, best spins, would be a 10 and a 10. Then I could get a 10 on the first one, 9 on the second, 10 on the first one, 8 on the next one. So all those work if my first spin was 10. Okay, well, what if my first spin was a 9? Well, I could win if I get 9 and a 10 or 9 and a 9. After that, I'm not getting at least 18. If I go 9, 8, now I've got a sum of 17. If my first spin was an 8, well, the only way I'm going to do it is doing an 8 and a 10. Well, there's 6 possible ways of getting a sum of at least 18. So I have 6 out of 100 possibilities, or 350 is. Now, for the later ones, if I do it with 3 spins, well, now I'm going to use Wolfram alpha again. So I took this expansion. I took all the spins, 1 through 10, and I cubed it, and I'm looking at which ones do I have numbers that are at least 18. And there's a lot of them. So I have to go through and find it. Let's get closer. So I'm going to add all the coefficients for any of these guys where the sum was over 18. So all of these, and at least 18. So I have to include this one too. So when I added up all those numbers, all the coefficients, 1 plus 3 plus 6 plus 10 plus 15, I got 425. There's a total of 1,000 outcomes because it's 10 times 10 times 10 for 3 spins. Each time I got 10 choices. So 17 out of 40, or 0.425. If I did it 4 spins, now I've got 10,000 outcomes. And I just changed the 3 to a 4. And this is what you get. And it's a huge expansion. Now, to me, it's too hard to go over and look at all the ones that are over 18. And now you figure, I should be able to do it in 4 spins, which is true. So I'm looking for the ones that fail. These are all the ones that are not at least 18. So going down all the way across all these. And if I add them up, I can't write underneath that part. If I added up all those, all the numbers that are less than 18, there was 2,240 that were less than 18. Therefore, if I take 10,000 minus 2,240, then that will tell me the ones that are at least 18. And that makes there's 7,760 that are at least 18, or 0.776. So if you're doing it some other way, take advantage of that. If this is the way they intended you to do it, well, now you see kind of what to do with these kinds of problems, just to get the expansion and then looking at the different combinations and utilizing technology. So that's what I think they may have done, was utilizing something like Wolfram alpha to be able to do these problems. Okay, hopefully this helps.